Today we're going to do another LeetCode with me session where I pick two completely random LeetCode questions and solve them on the fly, no prep. I'm not going to show you how to solve them, I'm just going to solve them and you can see my raw thought process and any mistakes I make, things like that. I think this is the fifth one we've done so far, and every time I make one of these, people always ask for more, so we're going to start doing these every other week. Okay, let's start with the daily question as always. You are given an m by n integer matrix grid and an integer k. For every contiguous k by k submatrix of grid, compute the minimum absolute difference between any two distinct values within that submatrix. Return a 2D array answer of size m minus k plus 1 times n minus k plus 1, where answer ij is the minimum absolute difference. The submatrix whose top left corner is ij in the grid. Okay, I'm just reading through the examples right now just to kind of get an idea of what is going on here. Because this is a 2D array, a 2D matrix, it will probably be helpful to visualize what's going on. So let me pull out my iPad and draw out these examples. Okay, so let's draw this first example here. So we have 1, 8, 3, negative 2, and k is 2, so this is our submatrix as well as our matrix, and minimum absolute difference. So the numbers that are closest together, so that would be 1 and 3 right here with a difference of 2, and that is in fact our answer. Here, when k is 1, there's only one distinct element, so there's not going to be a difference. That is something to note. When k equals 1 equals, that's an edge case, so the output is always going to be 0. Bigger grid, and then k is 2, so our only two submatrices are this and this. So here, closest is 1 and 2, and then here closest is 3 and 3, but they're not distinct. So is it 3 and 5 then? Yes. And then we have those two matrices that we then make into this matrix where we have a difference of 1, and then here we have a difference of 2. I think I'm getting it. What we need to do is there are several steps. First off, we need to figure out every possible k by k submatrix. And then from that submatrix, we need to figure out the two closest elements. Now, that particular part I already have an idea of how to do. When we get all of the elements in the matrix into one flat list, then we order that list, okay, like pre-sort the list, and then check the pairs that are next to each other, keeping track of a minimum value, as long as that value isn't 0, because they need to be distinct. Let's go ahead and get our comment template out. Okay, so there's going to be an outer loop where we figure out each k by k submatrix. So some of our edge cases would be, is k larger than the dimension, either of the dimensions of the grid? Is that ever a thing? Okay, it will not be. So minimum k is 1. First thing that comes to mind, again, the edge case. If k equals 1, everything is going to be 0. The only thing to consider then is it's not literally 0. We have to still return a matrix, kind of like this. And we need to figure out the dimensions of the matrix. The dimensions of the matrix will simply be the same as the dimensions of the grid. Otherwise, it's kind of a sliding window situation here, but it's kind of like a 3D sliding window in which we start with, well, let's see, for example, we would have our green window here is where we start, and then we slide it over 1. If it's a bigger grid, then we'd have to like restart down. So if it was like there, we'd have to also check here and here. Well, let's just write this out more broadly first, actually. So check every k in a sliding window, the 2D sliding window. Now that we know that we're using the sliding window pattern, we can actually realize that that flat list that we want, well, first off, that flat list that we want can be a set because we want to compare the unique elements, so we just need to turn it into a set and then order it. Although that will make the next step harder, because I was going to say, because it is a sliding window pattern, we have, although instead of a set, we might need to use a counter instead, like a counter map, because that way let me finally get to my point. My brain is moving faster than my speaking, as always. Okay, so because it's a sliding window, when we slide it over, so when we, for example, when we had it here and then we slide it over here, instead of recomputing everything, we just get rid of the 1 and 2 and add the 3 and 5. Our set is going to be 1, 2, -2, 3. And then we move it over. We're going to remove 1, 2, and then we're going to add 3, 5. But we have a double there. How do you want to solve that? Do we want a counter? Do we need a counter? Okay, so why would we need a counter? Because then when we slide something like here, for example, if there is more, we want to know if that 3 is gone or not. So let's say it's a counter. And then for each one, neighboring pairs. Can we sort a counter? I mean, dictionaries in Python are sorted, can be sorted. Should we do it that way? I think we should do it that way. That's the first thing that's coming to mind. For each one, check pairs that are neighbors and keep track of minimum. And then add to new matrix. Add to the result at the end of every loop. Yeah, so that's I kind of started writing out the approach already, so intuition is more like basic first thoughts, but we kind of started writing this out already. It'll be the time complexity of that. So we have an m by n matrix. We're going to be checking how many submatrices. Well, actually it's this. M minus k times n minus k, which is how many submatrices we're going to be checking. So I think it's that, actually, of m minus k, n minus k. And then space complexity, it's going to be k squared because we're going to store that in the counter. Okay, see if we can start writing the code. All right. First thing we do is the edge case, of course. If k is equal to 1, then we want to I in... Let me just think about the dimensions of this. So the inner one will be, this will be the inner one, and that will be the outer one. So how many of those rows do we have is how many rows we have in the grid. And then inner ones we have for I in length of grid of the row, inner row. And then what are the restrictions on the length of the grid? Yeah, so we have at least 1 always, so we don't have to check that edge case. I just want to quickly test that that's how that works. I'm assuming this test case will be here. No. Int object. Yes. We need a range. Okay, perfect. That is exactly what we wanted. So we got that edge case taken care of. And then check every submatrix K. So our window is going to be a counter. We're going to expand the window. And then after that, we're going to move through the window. So first we're going to expand the window to include k this way and k that way. So let's say if k equals 2, like in our example here, when I is 0, we want to add... Let's just start with a list real quick. Window, append, I'm going to append grid I, 0, 0. Oh yeah. And then for j in range k as well. So we want to say 0, 0, 0, 1, 1, 0, 1, 1. Okay, so that is expanding our window, then moving our window. For I in range, of course, we can quickly see how long our answer is going to be. Is going to be m minus k. So once again, if m is 3 here, k is 2, we need to go 1 more. So we first want to remove the outgoing, and then we want to add the incoming. This is all in the sliding window pattern. Oh yeah, and let's not forget here we want to check solution or add to result, but we'll deal with that after we've done the outer logic, aka getting each submatrix. Let's remove the outgoing, which is going to be grid I minus 1, and then, oh shoot, this is kind of difficult to do. This is racking my brain a little bit because I've not done sliding window in 2D before. So, okay, let's think about this. So maybe what if we just do it for this case and not try to generalize it? And then afterwards we try to generalize it. So we're moving from green to blue. We're removing 1 and 2, which is grid 0, 0, and also grid 1, 0. Grid, that's going to be 0, 2, and then 1, 2. Okay, I think I'm seeing the pattern. So I think that the number of times you want to do this is k. So for j in range k, we want to remove j, and then we can just do this. Move outgoing and append incoming. Yes. Because that's one of them. This one was also shouldn't be hard-coded, but let me figure that out. So I think it's, so I in range m minus k, it's going to be 1, m minus k plus 1. And then it's going to be I minus 1. And then this is going to be 1, I minus 1 plus k, I believe. And if I'm wrong, and I just leave this, I'm going to be so screwed up once we actually get to things. That is just going through the first row. So if we need to go through more rows, it's not going to be fun. I just want to go through this step by step and make sure I'm doing it right. So I'm going to open up VS Code and have things print. Yes, okay. Let's turn off Copilot. We don't want to be given the answer. Okay, M. M's not a thing, right? So it's, what is it? Is it grid? I think it's the grid length. Okay, so I just want to see what the window is going to be for, let's say I want to know for this one, and that's a 2. Let's try it. Actually, it might be that. It might be n instead. So 1, 2, 2, 3, that's right. Negative 2, 2, negative 2, 2, 3, 3, what? It should be 1, 2, negative 2, 3, negative 2, 3, 3, 5. So these two are correct. This one isn't. This is an intermediate. Am I printing in the wrong place? I believe I am. Yes, I am printing in the wrong place. So this is every window. This is every window that we have. So that's good. Now, if we have a height that is bigger than k, we will need to also move down. So something like this, and then we have to go here. Okay. It's really a brain workout. So now we need an even bigger for loop outside here. So for, I can't use I, range, okay, so it's going to be 1, no, it's going to be 0 to the length of the grid, vertical wise, so that is correct, minus k. So if the grid is 3 and k is 2, 3 minus 2, range 1, so that's perfect, I think. Are we good? No. That then does things we don't want it to do. Oh, maybe here? Oh, that's even worse. Okay. Minus k plus 1. Is it minus k plus 1? Yes. No. Yeah. Yes. 0, 0. Right. So if we had none of this, we would still want it to go through once, even though len grid is 2 and k is 2, so that would be in range 0. But we want it to go once, so for it's plus 1. I think our next step is to then make that function that checks for the minimum distance. So let's actually define that as a separate function. What do we call it? The list. We can't call it a list. That's a reserved word. Is it? No, it's not. Self list. Is that all we need? Yeah, that's all we need. We want to sort it. We then want to go through it. For element in list, that is a reserved word, isn't it? I don't like that. Let's just, yep, might be a reserved word. For element in list, actually, we don't want to have every single one. So we actually want to go for I in range, length of list, and we want to go 1. And this will be for sure a thing, because if it's only 1, then it won't even be here. It will be caught here. List at I minus list at I minus 1. And we want to have a minimum be infinity, and then update the minimum. Keep forgetting that I can't use reserved words. Okay, why is this not accessed? Are you just stupid or what is going on here? Oh. There we go. I think that's it. Okay. Now we need to do that. So we have a result and then we want to add to the result here. So min distance of the window and then result 0, 0. We want that to already be a thing, right? So actually we're gonna put that and then so that we can later replace. So we're going to already have result just be full of zeros. And after that, we just replace things. I don't get it. Actually, I don't get it at all. Oh, we're not returning anything here. We must say that we are returning an integer for sure. Wait, but if it's infinite, we want to return 0, right? If there are no unique elements, the answer will be 0. So if it's still math infinity, then we'll return 0. So mini is then we... Ternary operations are horrible in Python. Or not horrible, but like different than Dart, which I usually work in. So we're not going to use that. So we're going to say if it is, return 0, otherwise return that. Now that is the window we're going to be at. So instead of printing the window, we're going to result of the row of the column is going to be self-min distance of the window. And then at the very end, we want to print that solution. So I do believe that's all we need to do. Oh, and then at the end, let's not forget, we need to return result, okay? 1, 0, 0, 0, 0, 0. It's a 3 by 3 matrix, even though what we need is, no, we're doing a 2 by 3 matrix because it was a 2 by 3. And the actual answer we want here, I screwed up. I was wrong here in the assumption that I made because that is only true if k equals 1. Otherwise, what we want to do is the result is going to be 0 for I in. So the inner thing is going to be this size. It's only going to be m by n if k equals 0 because it's m minus 1 plus 1, n minus 1 plus 1. So it's just going to be m by n. Otherwise, it's going to be this. So m is going to be in grid 0 minus k plus 1, and then 0 minus k plus 1. That makes sense. And then we return result here. That way we have accounted for everything, I think. Yeah, so it's 1, 1. 1, 1. It shouldn't be 1, 1, right? It's 1, 2. Let's print window. Ah, we forgot. We cannot check. So if it's not the same, then we do that. Wait, is Copilot on now? Yeah, been at this for a bit. Okay, let's see. So now it's still 1, 1. Okay. We did not return anything. Why did we not return anything? Did not find anything here. So the min distance, so between Li and Li minus 1. Let's see what we're checking. 1 or 2, 2 and 1, 3 and 2. Why are we checking this twice? Oh, we don't need to check this here. Actually, row I minus 1, is that what we're doing? Oh my goodness, I'm getting so lost. Okay, let me think about this really clearly. How many times are we checking min distance? Just then. That is where we're going to put all this in F string to really explain to ourselves what is happening. So window min is setting at row I minus 1. Okay. We are not setting the last one. So I think here is where we need to set it again. Grid 0, length of grid 0. Length of grid 0 minus 1 because this was I minus 1. Perfect. So we just need to do that. Row length of grid 0. So inner length of the grid. What is wrong here? I believe it's actually minus 2, right? Because we want to set it at 0, 1, 0, 0, and 0, 1. Perfect. Don't know how I didn't catch that earlier. 1, 2, there we go. I do believe that is good now. Let's just get rid of these print statements and then come to regret that we got rid of the print statements when something else is not working, because that is always how that goes. Let us see if that is adequate to the LeetCode overlords. Perfect. Okay. So we get everything correct. Bet you it's going to be terrible on everything. It's not even right. Okay, yes. We didn't check, actually, our case here that we were talking about where we, dang it, my pencil keeps disconnecting. Basically, I got ripped off because I thought I was buying a refurbished pencil on eBay. It turns out I bought a knockoff Apple Pencil, and now it keeps disconnecting. And every time I try to connect, it will not put away the little pop-up that shows you connect to an Apple Pencil, and I have to turn off the iPad, like click the power button and turn it back on, and it's really annoying. And it also keeps disconnecting. And it also doesn't have pressure sensing. It's super annoying. But anyways, okay, so let's go back and think about what will happen if we have a third one. Let's say 5, 6, 7. Aha. Here we have an issue when our height of the grid is bigger than k. X is not in the list. Aha. Yes, so every time we move to a new row, we have to remake the window. So let's actually just, yeah, that was easier than I thought it would be, honestly. So expand window, and then after that, we move window. Yeah, like that. We move window, and then at the beginning of everything, window is going to be 0, or we're going to clear the window. And then the difference between 2 and 3, second one should be 1 as well, because it should be between 6 and 5, or 6 and 7. Which is where we regret removing the print statements. Okay, so what did we print there? So we had the window, min is this, and putting at row I minus 1, and then also do it here. 0, 0, 0, 1, 2, 3, 3, 5. Aha. So we're not actually going down properly. Why are we not going down properly? Because when we expand the window, we don't expand it correctly. How do we expand the window in relation to the row? The row is going to be, it's row plus k. No, row plus I here, and then j. Yeah, I think that's right. Dang, not right. 2, 3, 5, 6. Okay, that's correct. Okay, what's wrong here? So at least that's correct. At least we fixed that. Where are we having an issue? Line 46. Yeah, obviously line 46. Okay, line 37. That is still not in the list. What are we trying to remove? Aha, we're not taking into account the row once again. Okay, I think that's what we want. This time I'm removing the print statements once I paste it into LeetCode. Okay. If this even works. No, it doesn't. Why doesn't it work? Okay, let's test this test case. This is out of range. Len grid 0 minus 2. So why are we putting this at 0, 2 right away? Haha, that's not right. Putting at 0, 2. A, B. Where is this happening? This is happening at B. This only works if k is 2. So I believe, is it minus k actually? Is that how it works? Okay, now we're putting it 0, 0, 0, 1. Perfect. That's still wrong. So that's the minus 2. We need to be putting it minus k. Yes. Perfect. Okay, what's the solution? I don't know. But this needs to be turned into minus k. Okay, now let's try it. All right, there you go. Okay, so kind of middle of the road for both runtime and memory. We can probably improve the runtime by using a different data structure than a list maybe, and also by, instead of resorting it every time, doing insertion sort, something like that. But yeah, pretty good. I wasn't honestly expecting it to do that well on the first run after how many shortcuts I made. Well, we do normally do 2 problems, and even though this one did take a while, let's maybe do an easy one for our second question. That is not easy. I'm just gonna randomize until I get an easy one. Why are you giving me ones I can't even do? Hard? Are we out of easy questions or something? Goodness. Is this a sign that I need to just suck it up and do another medium one? So I know someone asked to do like graph questions last time. Again, I do these randomly, so I don't have a ton of control, but next time I will see if I can purposely find a graph one to do. I kind of forgot. I was going to do that today, but I forgot. I'll do it next time. Okay, winning player in coin game. You are given two positive integers, x and y, denoting the number of coins with values 75 and 10 respectively. 75 and 10. Those are weird coins, okay. Alice and Bob are playing a game. Each turn starting with Alice, the player must pick up coins with a total value of 115. If the player is unable to do so, they lose the game. Return the name of the player who wins the game if both players play optimally. Oh, so it's like a greedy thing? In order to get a total value of 115, what's 75 times 2? Ignore the fact that I don't know that off the top of my head. 150. So we can only have 175. So it has to be the optimal solution is, or the only solution really is 75, then 85, 95, 105, 115. So if x is 2 and y is 7, are there any examples where neither of them lose? Or not neither, or both of them lose? Oh, the first person to lose and the other person wins, I think is how it works. You pick up 1 coin plus 4 coins, so whichever runs out first, for whoever is currently playing, that's what's going to happen. For example, here, the first thing that's going to run out are the y's, because, so we have that, she's going to pick up 1x, and she's going to pick up y's, and then the next one, there's not enough. And for here, first Alice is going to pick up 1 of these and 4 of those. Then Bob is going to pick up 1 of these and 4 of those. And then he wins once again because we ran out of y's. So the limiting factor is if x times 4 is greater than y, then the limiting factor is y. Otherwise, it's x. Then, if the limiting factor is y, it's y entered a division by 4. And then, if it's odd, Alice wins. If it's even, Bob wins, I believe. So let me just think about this. So, if it's 7 divided by 4, it's 1. And then, if it's 11 divided by 4, it's 2. It's going to be y divided by 4, and then mod 2. So that's going to be 0. If it's 7, it's going to be 1. So if we say Bob and, nope, it's just Alice and Bob. So if it's x2, y7, so if y equals 7, it should be Alice who wins, Bob who loses. So we're actually going to say Alice wins, yes. And then if y is 11, Bob wins, right? Yeah, that makes sense. We already basically have that. So if that, then the limiting factor is y, and then we do this, we actually return this. Otherwise, the limiting factor is x, and then we just return x mod 2. Because there's only 1, Alice will win. If there's 2, Bob will win. Yeah, I think that makes sense. Okay, and then let's see if that works. Let's go. Okay, that was really fast. I'm glad. All right, that is a wrap for today's LeetCode session. As always, let me know how you would have done these down in the comments. And if this is your first time here, I'm a computer science student sharing my journey here on this channel. So if that's interesting to you, feel free to subscribe and stick around.